Okay, let's continue. For the heap sort, it is definitely a nice algorithm, but in practice, and you may find that we don't use the heap sort that much. Well, there is a even better n log n algorithm, that is the quicksort. We are gonna talk a little bit about quicksort later in this course, later in this class. Well, and your question might be, okay, so we have learned the heap sort, and there are really a lot of the components inside. And eventually you tell me the heap sort is not that useful. So why are we learning the heap sort? Well, wait for 1 second. Well, the heap as a data structure, that is a very useful data structure you can have. Okay, and especially the heap is very useful when we want to implement a priority queue. So what is a priority queue? A priority queue is a data structure. It maintains a set of the elements, and for each element there is one important attribute that is called the key. And our goal is we want to maintain a collection of the elements and using the key as the most important information, and we want to always grab the maximum of the key from this collection of the items. So we can add items into this collection. We can check what is the maximum of the key, and we can also extract the value or the item with the largest key. Okay, so well, you may ask, why is the priority queue very useful? And later we are going to talk about an example. But anyhow, let's make sure what are the important operations. So in third, we can put one element into the collection of the priority queue. And then we can check what is the maximum of the key. That is the maximum. And for the extract max, we can remove the item with the largest key, and then we take that out from the priority queue. Okay? So well, let me give you an example. Let's assume that we are a really poor institution. Okay? So we have a many people, and we share only one computer or one printer. This means for each of us, when we are trying to print something on campus, and this task will be sent to that single printer. So this printer might be busy. And well, if there are multiple items or multiple requests got sent to this printer, and then this printer will try to print the item or print the document with the highest priority. Okay, so say if a professor sends a document to a printer, and at the same time a student also sends a document to the printer, and then we want to say, okay, we want to put the student first. So I want to give the student a higher priority. So even though there are two tasks, they come to the printer at the same time, and the printer has to maintain a priority queue. So it always prints the document with the highest priority in the queue, so the student's document get printed. And then if there's no more item to be printed, and then the professor's one will go next. Or if when as the printer is printing the student's one, there are two more students sending in the test. And remember, the students have the higher priority. So well, this priority queue will guarantee that this printer always prints the student documents first before the professor's word. Okay, so let me do a hard example here. So let's assume there are 5 people sending in their printing task to the same printer at the same time. So we have a student 1, and the student 1's priority is 5, and then we have a student 2. And let's assume that this student 2 is a senior student. So well, the senior student got a higher priority, so priority 6. And then Professor Song wants to print something, and then his priority is 3, so I'm lower. And my chair sends another document to the printer, and my chair's priority is even lower. And eventually we have the dean. And the dean is, well, the most important person, so we want to print his document first. Okay, so all 5 of them, they send in to this printer at the same time. And if we want to do a priority queue using a heap, how do we do that? So first thing is, the first thing I want to try is, how about we put all the values into a list? So we have 5, 6, 3, 2, 10. Okay, we put everything to a list, and then if we just want to put that into a priority keyword, and what is that? So that is 5, 6, 6, 3, and 2, and 10. Okay, so this is not really a heap, right? And how about we build a heap? So we have to heapify what nodes? We have to heapify the 6 and then the 5. Why? Because those 2 nodes are the only 2 non-leaf nodes. So let's touch the 6 first. So this 6, we have to swap with the 10. Okay, so we have the 10 here and the 6 here, and then we want to heapify the 5. So 5 and 10, there should be a swap. So we want to put 10 here and 5 here, and then we want to touch this 5 again, and 5 and 6, another swap. Okay, 6 and 5. So, well, after doing the build the max heap, and then we do have a heap. And for this heap, and why do we say this is priority queue? And for this collection of the printing tasks, which one has the highest priority? That's the root, right? So because we are making use of the property of a heap, and then the top one always has the priority. So, well, let's see. Well, how do we find the maximum? And what is the time complexity? That is O1. Why? Because we always have to just grab the root. So that maximum is a O1. So the next question, which is a harder one, so how about we do a get max? So is that called get max? Give me 1 second. Extract max. Okay, so extract max. So when we are doing the extract max, this means we are removing this 10 out of the priority queue because that printing task will be handled by the printer. So the 10 will be gone. Okay, so we want to remove the 10. So after we remove the 10, now we have a problem. How do we rebuild the heap? So well, this is the idea. How about instead of when we remove the 10, we can use the last leaf to take the position of the removed root. Okay, 10 is gone, and then we want to do what? We move the 5 from down here to the root, and after that we have to fix the heap. So we want to do a heapify on the root. So we want to move this 5 down. Okay, so 6 will be here and 5 will be here. So for the extract max, what do we do? Number 1, we take one of the node out, and number 2, we want to put the last leaf to take the location of the root, and then we want to do a heapify. And remember, for a heapify, that will be O log n, right? So this is the cost of doing an extract max. Okay, so now we say, okay, the dean's work has been done. Okay, and let's do one more thing. And let's say we have the chancellor. So the chancellor is an even more important person. So how about we give him a priority of 15? Okay, and then the next question is, how do we do the insert? So for the insert, well, the easiest thing is how about we just add a new node to the end. So 15, and then we add it to the end. And what's the problem? The problem is there's got to be a way to bubble this value up. So well, 15 has to be bubbled up and bubbled up again. So instead of using a heapify, which is to drag one of the node down, now we also need a reverse version of the heapify, which is we have to use that, a reverse version of the heapify to pull a node all the way up, right? So well, the process will be, we want to say, okay, 15, you want to bubble up, and then we want to put the 15 here, and then this 15 is still doesn't belong to this place because this 15 can be further bubbled up, so we want to do that this way. So this 15 will be here, and then the 6 will be here. So well, what's the cost of the insert? Okay, for the insert, we add that to the tail of the priority queue, and then we bubble up, bubble up. So you may feel this is just a reverse version of the heapify, and you are right. Since heapify is O log n, so this is also O log n. Okay, so this is a very quick introduction about the priority queue, and let's go back to the lecture notes, and there will be a coding question in the homework 3, and in that question, and you will be required to implement a fixed length version of the priority queue. Okay, so this will be the task for the homework 3. Okay, and next, for this video, I talk about the priority queue. And for the priority queue, this is a really handy, there is a really handy implementation using the heap. I'm not saying, well, the heap is the only right solution to implement a priority queue. But for priority queue, and remember, we only want to remain a kind of sorted collection of the items using the keys, because we only care about the max, right? So this gives us a feeling that using a heap is actually quite suitable for a priority queue. And there could be other versions. And for example, you can use binary search trees, and you can use a linear data type, for example, a linked list. But well, I would say the heap is the most handy version of the implementation if we are trying to do a priority queue. Okay, so in the next video, I will start a little bit about the quicksort.